All right, so today we're going to talk about, remember yesterday I said it was called the sine, well, yesterday it was sine, cosine, and tangent functions. Now we're talking about the actual values of these, and we are using their unit circle. So if you remember the unit circle from Algebra 2 Honors, today should be easy. Like, hopefully it's a refresher, but today should be relatively easy. If you don't, then you have to learn it. So in Algebra 2 Honors, sometimes it's given to you and you get to reference it, or you get to write it out in its reference. Like, I know when I teach, a lot of times I'll give a blank one and they kind of like fill it out so they can help reference. There is no such thing as that as your AP. There's no reference, nothing on your AP exam. So you've got to be able to do some recall on it. The good thing is that it's usually from your natural unit circle instead of coterminals, but we are going to talk about what that would look like, okay? So the first thing we have to talk about is this is what's called a unit circle. A unit circle is formed with a radius of 1. And then every coordinate point along this is formed by a special right triangle. So good review for standardized tests would be your 30, 60, 90 triangle and your 45, 45, 90 triangle. So every 30, 60, 90 triangle and every 45, 45, 90 triangle have a special ratio of their sides. Okay, do we remember this? Ish? Yeah? This hopefully was geometry and algebra 2. So in a 30, 60, 90 triangle, the ratio of the side lengths opposite the 30, which is the smallest side, would be A or X. You could put whatever variable you want, but a lot of times we use A. Opposite the 60 is your middle length side. This is A root 3. And opposite the 90 is your longest side because it's your hypotenuse, and this is 2A. So if you were given any one of those sides, you should be able to find the remaining ones. We do that a lot in geometry, and also it comes up in algebra 2. But if I gave you the length of one of those sides, you should be able to find the other one. Now, what's special about the triangle that is now put in our unit circle is our A is 1. So now we know specifically the side lengths, which 30 degrees, 60 degrees, 40 or 90 degrees, the specific side lengths would be 1, root 3, and 2. Because our A is 1, because our radius is 1. Which means if I asked you to find the sine, the cosine, or the tangent of 30 or 60, we could do opposite over hypotenuse. We could do adjacent over hypotenuse. If I asked you for tangent, you could do opposite over adjacent. And it takes time, which is totally fine. That's one way to do it. But now you have to know that 30 degrees is the equivalent of pi over 6. 90 or 60 degrees is the equivalent of pi over 3. You have to set up your triangle. You have to set up the ratio. So is it possible? Yes. Right triangle is definitely one way to find the values of sine and cosine tangent of special angles. But faster than that is learning your unit circle and then being able to pull from your memory your coordinate points. So that's your goal, okay? If I go to 45, 45, 90 triangles, every isosceles right triangle, which would be a 45, 45, 90 triangle, has the ratio of sides that are A, and A root 2. And when I pull that into the unit circle, we are making those A's 1. And so it'd be 45, 45, and opposite those two would be 1s, and opposite the 90 would be root 2. So again, if I ask you for the sine of 45 degrees, or the cosine of 45 degrees, or the tangent of 45 degrees, you could use SOHCAHTOA to find it. And that is one way to do it. But you would also have to know that 30 degrees is the equivalent of pi over 6. Because when we convert from degrees to radians or radians to degrees, well, degrees to radians, we multiply theta by pi over 180. I don't want you to have to do that, though. I would rather you know it, like by recall. 30 degrees is pi over 6. 60 degrees is pi over 3. So the denominators are the reverse of the leading numbers in the angles, if that helps you remember it. 30 is the over 6. 60 is the over 3. And then 45 degrees is pi over 4. If you can understand that, then the rest of it hopefully goes a little bit easier. Yeah. No, you get nothing. Nothing. Not even a blank one to fill out because you can't use that as a crutch. So for me, if I wanted to use the unit circle, I would just make which I'll tell you when we're done with filling this in today, I would just make a little note for myself of the coordinates. But also by the time May rolls around, this is hopefully so deeply rooted into your brain because we're going to use it so much that you don't even need to write it down anymore. You just know it. But it is something like we use this for so much moving forward that it's going to get like, hopefully, like it's there. Okay. All right. So if we put that now in our circle, notice there's no degrees on this because everything, sorry.
For this quiz, are we going to get like the unit circle to fill in?
No. But and I would say by the time, I'm going to hopefully get you to the point that you don't need it. If you just know the over 6, the over 4, the over 3, you should be able to do everything. Okay? That's my goal, is you don't need it. It's a waste of time to fill it in if you understand it. So that's my goal, to get you to the point of understanding it enough that you don't need it. Yeah. Friday. All right. So this is a completely filled out unit circle with just radians and coordinate points.
Do we need to have the unit circle memorized by Friday?
No, again, I'm going to get you to the point that you understand it enough that you don't have to know the whole thing. Okay, I promise you.
So do we get this on the quiz?
No. Move past it. You're going to be okay. I promise you. Okay? All right, so if you look at this circle, right? Again, notice there's no degrees because in the AP content there's no degrees. It's only radian based, okay? But there is a pattern here. And the pattern is that first of all, we know these quadrant angles. We talked about them yesterday, right? 0, pi over 2 is at the top, pi is on the left, 3 pi over 2 is at the bottom, and then we double back around to the 2 pi. Those we talked about yesterday, and again, those are the foundation of how you start it. 0, pi over 2 at the top, pi on the left, 3 pi over 2 at the bottom, 2 pi back around, okay? Then every angle closest to your x-axis is an over 6. So an over 6, an over 6, an over 6, and an over 6. Every angle closest to the y-axis is an over 3. Over 3, over 3, over 3, over 3. And every angle in between is an over 4. Now, if you take all of those angles, and obviously the ones that are in the first quadrants are your pi over 6, your pi over 4, your pi over 3, because those are 30 degrees, 45 degrees, and 60 degrees. So anything that just has pi in its numerator is in my first quadrant. But then as I move around this circle, notice what's happening to just the fractional part of my angle. Ignore the pi. That is 2/3, that is 3/4, and that is 5/6. And all three of those angles fall between 1/2 and 1, right? Because this is going to be from 0 to 1/2. This is going to be from 1/2 to 1. This is going to be from 1 to 1 1/2. And this is going to be from 1 1/2 to 2. So if I take just the fractional part of that and I convert it to a mixed number, I should know where it falls just based on those 4 quadrant angles. In Algebra 2, we go way beyond this and we talk about 13 pi over 6 and 17 pi over 4, but your AP exam keeps it to your initial unit circle, not the coterminal angles. I'm going to teach you how to find those anyways because that could be standardized test stuff, but the good news is that it is basically from what you're looking at right now, okay? So then if that's true, instead of memorizing my whole unit circle, what I want you to memorize is the coordinate points at each of those spots. So every over 6 has the coordinate point that is √3 over 2 and 1/2. Every over 3 is the reverse, 1/2 and √3 over 2. And every over 4 is √2 over 2 and √2 over 2. If you know that, and you know which one is which, your x and your y, then it doesn't matter. You don't need your full unit circle in front of you. You can say, where does this angle lie? What quadrant? And then, is it an over 6, an over 4, and over 3? And you're done. So we talked about it a little bit yesterday, but if this is a unit circle, then my radius is 1. So now my sine is just y. My cosine is just x, and my tangent is y over x. So I would say go a step further and learn your tangents. If you can memorize these plus your tangents, and you know all students take calculus or the signs of where you're at, you're good. You don't need that full unit circle because you can apply it, okay? So the tangent at over 4, they're both the same, right? So y over x would be 1. The tangent at the over 6, if I put that y over the x and I do keep change flip and I get to the end, it's root 3 over 3. And what helps me memorize that is that it takes 2 3 to make a 6. So I need a 3 in the top and a 3 in the bottom. 3 plus 3 gives me 6, which is the denominator on pi over 6. That's how I remember it. And then root 3 is the tangent of every over 3. If I did the y over the x, keep change flip, they cancel out. And that helps me remember it is that I only need 1 3 to get to 3. So if I just know this is my cosine, this is my sine, and those are my tangents. If you could memorize that, that's all you need. Then you have to figure out what quadrant does it lie in, and that determines your sine. That's it. You will get there, I promise you. All right, so go to the blank one. Fill in at least the quadrants and your first, like the quadrantal angles, so the top, bottom, left, right, and the first quadrant, okay? What's on the right-hand side coordinate or angle-wise? 0. What's at the top? Pi over 2. What's on the left? Pi. What's on the bottom? 3 pi over 2. And where do we finish? 2 pi. Now, what's the angle closest to the x-axis? Nope. Closest to the x-axis has the biggest denominator because you're making it the smallest, right? Pi over 6. Now, pi over 4 is the in-between. Pi over 3 is the top. It goes 6, 4, 3, 2 is at the top. So it goes down, because if you think about it, if you were converting, you're dividing by 6, that's smaller. Dividing by 4, it's a little bit bigger. Dividing by 3, it's a little bit bigger. Dividing by 2, it's a little bit bigger. Now do the coordinate points. So at the over 6, in the first quadrant, this is root 3 over 2 and 1/2. At the over 4, it's root 2 over 2 and root 2 over 2. And at the over 3, it's 1/2 and root 3 over 2. And then add on your tangents. At the over 6, it's root 3 over 3. At the over 4, it's 1. And at the over 3, it's root 3. And we didn't do the tangents on the quadrant angle, so let's think about what happens there, okay? What would be the coordinate point at 0? No, I moved to the right one, right? My radius is 1. So if I move to the right one, what's that coordinate point? 1, 0. If I do y over x there, what's your tangent? 0. Now go to the top. What's that coordinate point? 0, 1. If I do y over x there, what's the tangent? Undefined. Do the other quadrant angle. So if I move to the left at pi, what's the coordinate point? -1, 0. Y over x, 0. So tangents, zeros on the x-axis, okay? And at the bottom, coordinate point would be 0, -1, and the tangent would be undefined. Now, if you understand, like there's a trick to the radians, and I'll teach it to you, but you don't need to know this if you understand the 0 to 1/2, 1/2 to 1, 1 to 1.5, and 1.5 to 2. Because if you could take every one of those fractions and figure out which of those it falls in, you can use it. But there is a trick to the radians, okay? Every one that's closest to the x-axis is your over 6. So this one's going to have a denominator of 6. This one's going to have a denominator of 6. This one's going to have a denominator of 6. Everyone closest to the y is the over 3. So this one's going to have a denominator of 3. This one's going to have a denominator of 3. This one's going to have a denominator of 3. And then the one in between is the over 4. They all have pi in the numerator. In the first one, it's only pi. In the second one, I'm going to add to it, but make this thinner. And then in the second quadrant, so first quadrant, they are what they are. I don't mess with them. Second quadrant, my numerator is 1 less than the denominator, because if it had equaled the denominator, it'd be 1, right? So this is less than 1. It is 1 less than the denominator. So it is 2 pi over 3, 3 pi over 4, and 5 pi over 6. In the third quadrant, it is 1 more than the denominator. So it is 7 pi over 6, 5 pi over 4, and 4 pi over 3. And in the fourth quadrant, we're bigger than 1.5, but less than 2. So it is 1 less than double, or 5, 7, 11, if you memorize that. So this was 1 less. This was 1 more. This was 1 less than double, or 5, 7, 11, if you memorize that. So what I don't want you to do is waste your time going in and putting in all those coordinate points, because hopefully when you see it's an over 6, I know the coordinate point, and now I just got to figure out what quadrant it lies in, right? So if it's an over 6, it's root 3 over 2, 1/2. My tangent is root 3 over 3. Now what quadrant is it in? And no, all students take calculus, because that will tell you the sign that's supposed to be. Or you know your x and your y's. Like if it's in the third quadrant, x and y are both negative, the tangent's going to be positive. In the second quadrant, I'm moving left and up. So my x is negative, my y is positive, my tangent's going to be negative. That kind of thing. So those are the things you want to eventually get to, okay? So the good news is that's the hard part of this section, like knowing it, because the rest of it is simply recall. So they look like this. Wait for it. Okay, go to example 1. It says find the exact values of the indicated variables. Sure. Now, try to recall, okay? First of all, if A says cosine of 7 pi over 6, my angle's an over 6, yes? What's the coordinate point at the over 6? Root 3 over 2 and 1/2. Which part of that is the cosine? The x, which is root 3 over 2. That part, got. Value, got. Now I got to figure out my sign. So what is 7 over 6 in a mixed number form? Nope. 1 and 1/6, right? Where would 1 and 1/6 be in my quadrants? Quadrant 3. What's true about cosine in quadrant 3? It's negative. So there's my sign. That's it. I'm going to go back to the negatives. I'm going to go, yeah. I'm making it to a mixed number. Unless you memorize those angles, but you don't need to. Like if I know that that's a 1 more, right, that my numerator is 1 more than my denominator, then I know that's third quadrant. If you use that trick. So it's pi, right? But in the second one, it's 1 less. Third one, it's 1 more. And the fourth one, it's 1 less than double, right? Like if I double my denominator, is it 1 less than that, then it's in that quadrant. Yeah? So I can look at it that way, like 7 is 1 more. If it's 1 more, it's in the third quadrant. But I can also say it's 1 and 1/6. And do your even odd trick. 1's on the left. 1/6 would be less than 1/2, so it's in the third quadrant. All right, now, so go to C. I said I'm going to go back to the negatives. Yeah. Negative root 3 over 2. All right, go to C. What's happening at 0? What's your coordinate point? 1, 0. What part of that's your sign? The y, which would be? 0. Go to D, sorry. Over 4. What's your coordinate point at over 4? Root 2 over 2 and root 2 over 2. What part of that's the cosine? The x, and it doesn't matter because it's an over 4. But the x, square root 2 over 2. There's my value, yes? Now, where is 7 pi over 4? Fourth quadrant. It is 1 less than double, or it is 1 3/4, which would go into the fourth quadrant. What's true about the cosine in the fourth quadrant? Positive, that's my answer. Is it starting to click? Yes? Okay. All right. I'll take That's better than All right, go to F. 3 pi over 2. Where's 3 pi over 2?
Negative 0, negative 1.
0, negative 1. It's at the bottom, right? Which part of that's the sign? The negative 1. I didn't circle that one. We good on the positives so far. The good news is there's like a finite amount of questions you could get asked on this because it's if you pull it from your unit circle, there's only so many angles we could ask, right? These types of questions in your AP will never, like it's not going to be a multiple choice that says find the sine of 7 pi over 6. But it gets built into an FRQ. So it will say like find the tangent of this, that's A, and then, or like I, and then double I is something else, and then triple I is something else, but it gets built into that stuff. All right, so now let's talk about the negative angles. The negative angles, there's two ways to do it. Either literally go clockwise. So if it was negative 7 pi over 6, I would still go to the 1 because that's 1 1/6. But then I would move clockwise to figure out my quadrant, okay? The other thing is you can find that angle as though it's positive. So I would figure out where positive 7 pi over 6 is and then fold it in your mind like a hamburger, and where it reflects is where it would be negative. I'm going to draw it out when we get to that point, but that's one way to do it. So where is positive 7 pi over 6? We're in the third quadrant, right? This is 7 pi over 6. Negative 7 pi over 6 would be literally, if I could fold this down and overlap it, where does it go? And it would go here. So reflect it over the x-axis. And now I know where the negative version is. So you could do it either way. I could say that's negative 1 1/6. 1 still goes here, but the negative tells you go in this direction instead of this direction. Or you could do the hamburger trick. I don't care which one you do, okay? So I already said, so we know which quadrant is negative 7 pi over 6 in? In the second quadrant, and we already did the cosine of 7 pi over 6. It's root 3 over 2. In the second quadrant, is my cosine positive or negative? Negative. All right, so go to E. Let's do the angle first. I mean the coordinate point first. What's the coordinate point at an over 3? Well, what's the coordinate point? 1/2 root 3 over 2. Okay. So which part of that's your sine? The y, root 3 over 2. And now we got to figure out where negative 4 pi over 3 is. So if you do the hamburger trick, where does 4 pi over 3 live? Third quadrant. Fold it in half so it goes to the second quadrant, right? If you do the 1 1/3 trick, this is negative 1 1/3. The odds start on the left, but instead of going counterclockwise, we go clockwise, and 1/3 is less than a half. So I'm in quadrant 2. In quadrant 2, is your sign positive or negative? Positive. Questions on that one? Okay. Try these. All right, tan at 7 pi over 6. First of all, it's an over 6, so it's root 3 over 3. That's in the third quadrant, so it's positive. Tangent at negative 3 pi over 4. Positive 3 pi over 4, second quadrant. Fold it down. It goes to the third quadrant. It's an over 4, so it's 1, and it's positive because it's in the third quadrant. 4 pi over 3, my tangent's root 3. 4 pi over 3 is also in the third quadrant, so it's positive. And then 3 pi over 2, top or bottom, tangent's undefined. How'd you do? Good? Okay, great. All right, so the only thing that changes, well, we're going to do 2 more things, okay? But what could happen, notice that these are like with a radius of 1 up to this point, right? So unit circle has a radius of 1. So what happens if we change the length of the radius is really you just have to take that same coordinate point and multiply it by the radius. That's all you have to do. So if it says you have an angle and the angle produces the coordinate points we just talked about, and then it says, but the radius is this, and it's not 1, then to find the x coordinate and the y coordinate, you simply just multiply it times the radius. So I'll figure out what coordinate it was, and then I'll multiply and distribute in the radius. That's all you have to do, okay? So if it was something at pi over 6, I would know my coordinate points root 3 over 2 and 1/2. And if my radius was now 4, I would multiply both of those by 4. That's all you have to do, okay? And it makes it a lot complicated. It puts it in a paragraph, so it scares you because it's lots of words, but it's all you have to do. Example 2 says, in the xy plane, an angle in standard position measures 3 pi over 4 radians. Well, there's my angle, right? A circle centered at the origin has a radius of 6. Well, now I have a radius of 6. What are the coordinates of the point of intersection of the terminal ray of the angle and the circle? And that's literally just taking that radius, which is 6, and distributing it into the coordinate points that are at 3 pi over 4. What coordinate points at 3 pi over 4? So every over 4 would be root 2 over 2 and root 2 over 2. And then where does 3/4 pi live? Second quadrant. So what's true about those signs? X is negative, Y is positive. Distribute this in. 2 goes into both of those, so it'd be negative 3 root 2 and 3 root 2. Because it's in the second quadrant. So second quadrant, I move left and I move up. So I'd have a negative X, but a positive Y. Questions on that? Now that could be literally a multiple choice question on the AP exam. They just give it words, make it harder. All right, now we're gonna work in reverse. So now we're gonna find the radius given an XY coordinate point. If it gives you a coordinate point, first of all, if it's without a calculator or a standardized, like on your unit circle based, then it can only be a certain amount of coordinate points, and they would always reduce to be the same thing if it wanted the angle. These are just asking for the radius. So if it gives you the tangent, or if it gives you a coordinate point, or whatever it gives you to get the x and y, then to find the radius, you just have to do the square root of x squared plus y squared. Make it a triangle if you want the visual, but you're doing the Pythagorean theorem is all you're doing, okay? And then if it's asking you for the angle, then you have to make sure you pay attention to the signs on your x and y. So for example, if I said that a coordinate point was 2, negative 2, and it wanted to know what the radius is and what the angle is. The radius, I would just do the square root of 2 squared plus negative 2 squared, which is the square root of 4 plus 4, which is the square root of 8, or 2 root 2. That's how I find it. I'm doing the Pythagorean theorem because this would go to the right and down, and I can make a little triangle. So if you're visual and you want that, you would go right 2, down 2, and close in a triangle. And then you'd be looking for the radius, okay? If you want to know the angle, then you have to think reverse in your mind. So if I put y over x, in this case, my tangent is my y over x. So I would put negative 2 over 2, and I'd get the tan of theta is negative 1. Now, where is tangent? Which special angle has a tangent of 1? What's the denominator?
4.
The over 4. But it's a negative 1, right? So what 2, because there's 2 answers, what 2 over 4s have a negative tangent? Which quadrants? 3 and 4. The second and the third quadrant, right? Which is 3 pi over 4 and 7 pi over 4. But there's only, I did right. But there's only one right answer here, and it's based on the original signs. So if I drew it here, which quadrant am I in the original drawing? If I went right and down, what quadrant are you in? The fourth quadrant. And that's how you would know which of those 2 angles to pick. The answer there would be 7 pi over 4. We're going to do it again, but that's the concept. Use the coordinate points to find the ratio, figure out which special angle that is, and then use the original signs of the coordinate point to figure out what quadrant you should be pulling from. So last example is going to put those 2 together. In the xy plane, the terminal ray of theta in standard position intersects a circle of radius r at the point, negative 2, 2 root 3. What are the values of theta and r? So we need for both. My opinion is r is easier if you want to go there first. Do the square root of negative 2 squared plus 2 root 3 squared. You could do it. All right, so this is the square root of 4 plus 2 squared times the square root of 3 squared, which would be 4 times 3, plus 12, square root of 16, which is 4. So that's my radius. Now I want to know my theta, right? So I'm going to say the tan of theta is root 2 or 2 root 3 over negative 2. These will always simplify to be one of your special angle tangents. If you look, this becomes negative root 3. So what's the denominator if tangent is root 3? It's an over 3, that part I know. Where does negative 2, positive 2 root 3 live? Second quadrant. What's the over 3 in the second quadrant? What's the rule in the second quadrant? 1 less. So it'd be 2 pi over 3. Questions? So these can be weird coordinates, but they will always reduce. When I put them y over x, it has to be either 0, undefined, root 3 over 3, 1, or root 3. Those are your only options. Then you got to figure out your quadrant from there. Yeah. This, where like the messy part, this was squared, so I squared the 2, and I got 4, and I squared the square root of 3, and I got 3, which was 12. Yeah. So you're doing the square root of x squared plus y squared, or making a triangle and doing Pythagorean theorem. It's the same thing.